Now give the next reading of the question. The next question that we are going to study is a main book, part 2, chapter 1, question 1. It is from the part 2, chapter 1, question 1. Basically, this question is belongs to the stresses, but don't worry, we need some basic concepts of stresses. We will study these concepts later on, but before that, but we just need a few things about the stresses, so we can directly write down that relation. But the basically this question is totally related with the forces that we have seen. Only few relations of a stress we needed here in this question. So means stress means what? Sigma, force by area. Just we need this relation. Stress is equal to what? Sigma, force by area. We will see how to get this relation further. But before going further, first of all, try to read this question minimum 2 times. What you have to do? You have to read the question minimum 2 times. So please read the question minimum 2 times. Now try to see the scenario here. We have what? A uniform 5-meter long ramp. What we have? We have a uniform 5-meter long ramp. So this is what our ramp. Observe the scenario. This is what our ramp. How much is the length of this ramp?
It is 5 meters.
5-meter ramp. And how much mass is there? M is how much?
1.2 tons.
M is how much? 1.2 ton. 1.2 ton means how much kg? 1200 kilogram.
Yes, sir.
So mass is 1200 kilogram, is suspended at 15 degree to the horizontal. So this ramp, this is what a ramp. This is what a ramp. This ramp is making how much angle with respect to horizontal?
15 degree.
So this angle is what? A 15 degree they have shown here. So this ramp I have highlighted in green. This ramp is making how much angle?
15 degree.
15 degree to the what? Horizontal.
Horizontal, sir.
And to the horizontal by a two 15 mm diameter cables. So here we have what? Just observe the things here carefully. So here we have what? Two cables. So these are the water cables. See this one that I have highlighted now.
Yes, sir.
So this is water two cables. Huh? Now you may say, sir, here only one cable is visible. See, one behind the other.
Yes, yes, sir. It's a RAM. RAM will be having two cables.
Two cables. So these are the two cables. So these are the what? We have what? Two cables. One cable visible to us, behind that cable which is not visible to us, exactly behind.
Yes.
So
yes,
here
yes,
we have also number of cables are how much?
two cables.
So number of cables is how much? Two. Then dia of each cable, what they have given us? Dia of cable.
15 mm.
So 15 mm. 15 mm means what in meter? How much?
0.015.
0.015 meter. The cables are attached at 1.5 meter from free end, means from this end. Try to understand the things here carefully. So from here to here, from this point to this point distance is how much?
1.5 meter.
So from pre end, so cables are attached 1.5 meter from the pre end are at an angle of 50 degree above the horizontal. So above the ramp. So this cable is making these two cables. Here how many cables with us here?
Two cables. Two cables.
So these two cables are making how much angle with respect to this ramp? This ramp
50 degrees.
50 degree above the ramp. One end of the ramp is hinged. So here we have what? Hinge.
Yes, sir.
Using two pins. So here we have what? A hinge is here. So ramp is hinged using two pins. So number of pins are how much?
Two pins.
Number of pins 2. And what they are saying further? Using two pins, each of dia what? 30 mm diameter. So dia of each pin is how much?
30 mm diameter.
Diameter of pin is how much?
30 mm.
30 mm. So 0.03 meter.
Yes.
Then each pin is in double shear. I will explain you what is the meaning of double shear in upcoming discussion. Each pin is in what?
Double shear.
So here we have what? Each pin which is in what? Double shear. So before going further, please write down this discussion.
Yes.
Now, sir, take a 2 minute by yourself after completing the given things. Take a rough page. Take a 2 minute by yourself. Take a rough page and try to draw the drawing by yourself in a rough page. So now try to see the scenario here. What we are going to do further and how we are going to approach the things further. See the things here carefully. We have what? We have what here? Ramp. Ramp is making how much angle with respect to horizontal? 15 degree. So first of all, what we are going to do? Just don't write anything. Just listen my words carefully. So what we are going to do? We are going to draw what? So what we are going to do? We are going to draw what? First of all, a ramp. So what we are going to do? We are going to draw a ramp. So this is what our ramp. How much total length of the ramp here? They have given us. How much is the total length of the ramp they have given us?
The RAM is 5 meter long, sir.
So this is a ramp whose total length is how much? 5 meter long. 5 meter long.
Yes.
Ramp is making how much? So here one end is free and another end is hinged.
Yes.
So here we have what? A hinge. Observe the things here carefully. So this is what? A one vertical line. 1 minute, let me check it is vertical. So here we have what? A vertical line. So this is what? Here we have what? This is what? Hinge. And this ramp. Now I am going to draw 1 minute. This is. So this ramp is making how much angle with respect to horizontal?
15 degrees.
So this ramp is making how much angle with respect to horizontal? So with respect to horizontal 15 degree. So from here we are going to draw one dotted line. Just observe the things here carefully. Just we are going to draw one dotted line. I'm going to make this line as a dotted. And this angle will become how much?
15 degrees.
So this angle will become what? 15 degree. Now then here 1.5 meter from the free end. Here what we will have? So somewhere here.
Cables.
So somewhere here what we will have? Cables. So how many cables with us here we have?
Two cables.
So these are the what? Two cables. You may visible. Oh, these cables are what? Only one cable you may visible. But behind the cable there is another cable which is not visible to us in this view. So here we have what? So these are the what?
Two cables.
Two cables, and these cables are making how much angle with respect to ramp?
50 degrees.
So this cables is making how much angle?
50 degrees.
So 50 degree. So these two cables is making how much angle?
50.
50 degree. So these two cables is making how much angle? 50 degree. Any doubt in this discussion? You are getting
No,
my
sir.
point? So
No,
these
sir.
two cables are making how much angle?
50 degrees.
50 degree. So these are the two cables. Observe the things here carefully. Then 1 minute, I will shift little bit on this side so that we can add. Now the next thing will be what? Observe the things here carefully. From this point, I am going to draw a dotted line. See this one. What is the speciality of this line? See, what is the speciality of this line? This line is what? Exactly perpendicular to what? Perpendicular to the ramp. Huh?
Yes.
So this line is what? A perpendicular to the ramp. So this dotted line. Then another. So this dotted line. 1 minute. So another dotted line we will draw at this position, and then another dotted line we will draw at this position. So here we have drawn a 3 dotted line. Now tell me what will be this distance from here to here?
1.5 meters.
So this distance is how much?
1.5 meters.
So this distance is how much? And remember this dimension line must be exactly what? Parallel to the ramp.
Yes.
So this distance is how much?
1.5 meter.
1.5 meter. So this distance is how much? We have 1.5 meter. Then another dimension line, this one from here to here. Again this must be exactly what?
Parallel.
Exactly parallel to the ramp. So this distance is what? How much this distance will become what?
3.5 meters.
3.5 means total length of the ramp is 5 meters. So if you subtracted 1.5 meter, then how much length will remain?
3.5.
So we got a 3.5. Now then exactly at the center. So this is what they said in the question. We have what? A uniform ramp. What they said in the question, if you see the question, what they said uniform ramp. Uniform ramp, how much meter? 5 meter long. What they said?
Yes.
A uniform ramp, a 5 meter long. So uniform means what? A mass is uniformly distributed. So
Yes,
it
sir.
means what? Exactly where it will act. Exactly weight of the object where it will act.
At 2.5 meter. The G will be at 2.5 meter.
So center of gravity will act exactly at the center of
Yes.
this ramp. And we discuss, if you remember our discussion of the weight, suppose
Yes,
if you
sir,
go
yes.
to the discussion of weight of the object always acts vertically downward through the what? Through the which point? Through the center of gravity. Weight
Yes.
of the object always acts vertically downward. So whatever may be the position of the object, but it is like a tilted or vertical, horizontal, but weight always acts vertically downward through the center of gravity. We can show the weight in this way or this way. So
Yes, yes.
try to see the scenario here. So if you observe the things here carefully, so weight of the object acts what? Vertically.
Downwards and center of gravity.
Vertically downward. So let me compare with this reference position. So this is what our weight. 1 minute, I will show properly. I will use, generally for showing forces, generally I am going to use a red pen. So this is what a weight. Try to see the point. This is what a weight, and weight will become how much mass we have here. Mass is 1200 kilogram.
Yes.
So weight will become what? 1200 G.
Yes, sir.
So 1.2 ton. Na? So
Yes, sir. 1.2.
so it will become what? Weight will become what? 1200
100 kg.
1200 G.
Okay, 1200 G.
1200 into G. That is the meaning of this one. What is the meaning of this one? 1200 G. G here, G is not a gram. G stand for what? Acceleration.
Acceleration due to gravity.
Here G stand for what? Acceleration due to.
Gravity.
So this G stand for what? This G stand for what? acceleration due to gravity. So that is what? So 1200 g. Try to understand the scenario. G. 1200 g means here this value we will get in what? Newton. 1200 g.
Yes.
It is not a gram. This is g is not a unit. So 1200 multiplied by g, we will get a weight in Newton. Weight means what? Gravitational force.
Yes.
So this is what? Now we will assume let F. We will assume let F will be equal to what? Force in each cable. What we are going to assume? Let
Force
F is equal to what?
Force in each cable.
What we are going to assume? Force in each cable, and force in each cable in which unit? Newton. So how many cables here we have? How
Two
many?
cables.
How many cables here we have? We have a two cables. So here we have a two cables. So force in each cable will be what? So force in each cable will be what? So if you observe things here carefully, so here we have what? Two cables. Observe the things carefully. So this is what? So force two cables. So force in each cable what we considered? F. So force in two cables will be what? Tell me. 2F.
Yes, sir. Yes.
So force in two cable will be what?
2F.
2F. So here we have what? Two cables and force in. So here we have a two cables and force in each cable. So force in two cables will become what? 2F, because force in each cable is what? F. Any doubt in this discussion? Now what we are going to do? Our target in A part is what? What we have to find out? Stress in each cable.
Yes, sir.
What they are asking us in A part? Tensile stress in each cable. What is our target in A part? We have to find out tensile stress in each cable. How to get a tensile stress? For that purpose, just have a look here. So in A part, we have to find out stress. We will see in simple stresses and strain. In upcoming discussion, we will see tensile, this discussion in more detailed way. So stress in each cable we have to find out. So stress in cable, each cable will be equal to what? Stress means what? Force by area. So
Yes.
force in each cable is what? How much? F. And divided by what? Area of each cable, cross sectional area of each cable. We will calculate the force F, and area will be equal to what? Cross sectional area of each cable. It is circular cable. So pi by 4 d square diop square. So in this way we will get a what? Stress in the cable. But to get a stress here, what is unknown to us? To get a stress, what is unknown to us? F is unknown to us because
Yes,
diop cable is what? They have given us a diop cable 15 mm. So 0.015 meter we have already. So we have a diop cable. So what is unknown to us? We have a F. To get a F, what we are going to do? So to get a stress, what we need? We need a F. To get the F, what we are going to do? We are going to make a component C. F means what? Remember, what is the meaning of F? F means what? Force in each cable. And why
Yes.
we are showing 2F here? Why we are showing force to F?
cables.
Because of the two cables. So here, now what we are going to do? We are going to make a components of 2F. What we are going to do? To get the things further, what we are going to do? We are going to make a components of a 2F. And here, see, earlier, if you remember our last discussion or our theory of this chapter, we have
Yes.
seen components of a forces. What we studied? Components of a forces.
Yes.
One component X we have taken generally horizontal direction, Y vertical direction. Means
Yes.
one component horizontal, another component vertical.
Yes.
So here we have considered one component horizontal, another component vertical. But in this numerical, there is some twist in this numerical. So what we are going to do in this numerical? We are going to take one component along the ramp. Remember point. One component is what?
Along the ramp.
And another component will become then perpendicular to the ramp. So what will happen? So to make the thing simple, and why I am doing that, just give me 1 or 2 minutes. I will explain you why we are making a components like that. Because the things will become very, very simple if you take the component along the ramp, another component perpendicular to the ramp. So for making components, what we are going to do? We are going to form a rectangle. See, this one side of the rectangle is what? Perpendicular to the ramp. So we are extending this line, which is what which must be what, perpendicular to the ramp. Then another line, see this one, this will become what, tell me, parallel to the ramp.
Yes, sir. Yes, sir. This will be parallel to the ramp.
Parallel to the ramp. And then we will have another line, just observe here. So this line is what again, perpendicular to the ramp.
Yes, sir. Yes.
So here we have form a rectangle like this, and we are going to make this rectangle as what, a dotted. Observe the things here carefully. Very simple discussion. You are going to enjoy this discussion. And remember one point, always try to draw the drawings bigger. Never try to draw the drawing smaller. Always try to draw the drawing, always bigger drawing. So try to see the things here carefully. So one component. This will be the one component. Observe. You are getting. I am going to make it little bit dark so that it is properly visible to you. So this is what, a one component. This is dark component. This component is what, along the ramp. And this component will be what?
Perpendicular to the ramp.
Perpendicular to the ramp. And I will explain you why we are taking a components like this. Give me 1 or 2 minutes. I will explain you why. So this component, here 50 degree is with respect to this component. Here 50 degree, this 50 degree with respect to what? This 50 degree with respect to this component. So this component will become what? 2f cos 50.
Yes, sir.
And this component, then this component will become what? Another one.
2f sin 50 degrees.
So another component will become what? 2f.
Sin 50.
So in this way, what we have? We have a two components. Now see, we will see the benefit of taking the component. Suppose this is what, this point is what, our hinge point. This point is what? This point is what, our hinge. Suppose if you want to take a moment about hinge, what will happen? If you take a component like this, then this 2f cos 50, what happened to this 2f cos 50? It is directly going to pass through the hinge. This 2f cos 50, if you extend this line further, it is directly going to pass through the what?
Yes, sir. Hinge.
Hinge. So perpendicular distance of this 2f cos 50 is how much? With respect to hinge, 0.
Yes, sir.
So perpendicular distance of, and what is the, and 2f sin 50? We will get a directly perpendicular distance is how much?
Perpendicular distance 3.5 meters.
So we will get a directly perpendicular distance 3.5 meters. So see, making a components, how things will become easy. Because if you take a moment about a hinge, see, if you take a 2f directly, then you have to draw one perpendicular line, things will become very difficult. But if you take a components, initially you may feel, oh sir, taking a components are very difficult. But once you got how to take a components, then moment calculation and all other calculations become very easy. Initially you may feel difficult, oh, taking components are difficult. But once you understand how to take a components, then remaining things are very easy. Very easy. So you have to, our first task in mechanics is what we should become expert in how to take a components. And remember one point, it is not always that components, one component horizontal, another component vertical. According to situation, we will take a components. According to situation, and that things we will not get in one day. We have to do a lot of practice for next 1 or 2 months, and then you will get a familiar with how to take a components and all these things. So we got the components of 2f and one component along the ramp, another component perpendicular to the ramp. And why we are making? To make the moment calculation very simple. Now what about this 1200G? Same thing we are going to do for the 1200G also. And for 1200G, I am going to draw one line. See this one. 1 minute, before going for the components of 1200G. See, here force is going outward. Yes. Going outward. So components also what? From this point, forces. From this point of the ramp, force is going outward. So its components also what? Going outward. Now same thing happened to the 1200G also. 1200G what? Going outward. So its also components also what? Should go outward. So here what we are going to do? We are going to form a rectangle like this. 1 minute. I will form a rectangle in a proper format. And remember, always try to draw the bigger drawings. Bigger drawing things will make things very simple. If you observe this, I am using my entire screen so that things will become very simple.
Yes.
So this is what this horizontal line parallel to the ramp, and this line is what?
Perpendicular.
Perpendicular to the ramp. You are getting my point. Try to understand the scenario here. And we are going to make this rectangle as what? Dotted, dotted. Observe the things here carefully. What we are going to do? We are going to make this rectangle as what? Dotted, dotted. Now my question to you, what will be this angle? What will be this angle? Tell me. What will be this angle? This that I have shown in black one. This one. What will be this angle?
15 degrees, sir.
How does you come to know that it is a 15 degree? Answer is correct. 15 degree. So for that purpose, what we are going to do? Suppose if we extend this dotted line, just imagine that. If we extend this dotted line, so this will form a one right angle triangle.
Yes, sir.
They will form a what? This one, and
Yes.
this one. So this angle is 90 degree. So what will this angle will become? How much?
That will be 75 degree.
75 degree. So sum of these two angles is what? 75 degree.
Yes.
So this angle will become how much? So let me enlarge little bit. So this angle will become how much?
75 degree.
75 degree. And sum, this is what? A 90 degree.
Yes.
This is what? A 90 degree. So then sum of these two angles must be 90 degree.
Yes.
So sum of, so this is 75 degree. Then what will become this one?
15 degrees.
So this one will become how much?
15 degrees.
15 degree. You got this one? So
Yes,
now
sir.
we have now the time to take a components. And how to take a components? One component is what? Along the ramp. See this one? Here one component is what? Along the ramp. I'm going to make this component little bit dark. And another component is what? Perpendicular to the ramp.
Yes, sir. Yes.
So here we have two components. One component along the ramp and another component
Perpendicular.
perpendicular to the ramp. Let me erase this one. So, and this angle is how much? This angle is how much we have? 15 degree. So what this component will become? So this one. What this component will become? 15. Sorry, 1200 G cos 15.
Yes, sir. 200 G cos 15 degrees.
And then this component will become what? 1200 G
Sin
15. You are getting my point?
Yes, sir.
So whatever angle. So here angle with respect to this component perpendicular to the ramp component. So this will become what? 1200 G cos 15. And this component will become what? 1200 G
Sin 15.
sin 15. And what is the benefit of taking a component like this? We will see this one benefit. I will extend this line further, dotted line. I'm going to make this line as a dotted. So now tell me, can you tell me this distance from here to here, this distance, can you tell me?
It will be 2.5, sir.
It will become what? A 2.5. Now what is 2.5 meter? So if you see, what is the benefit of taking components like this? One is along the ramp, another one is perpendicular to the ramp. If you take a moment of 1200 G sin 15, what is the moment of 1200 G sin 15 about this hinge point? What is the moment of 1200 G sin 15 about this hinge point?
It will be 0, sir.
Why 0? Because perpendicular distance is how much? So
Okay,
this, so this,
perpendicular distance is 2.5 meter.
so how it is 2.5? For 1200 G sin 15, how it is 2.5? It is the 0, na?
Yes, sir.
So this 1200 G is directly going to pass through this hinge, na?
Yes, sir. Yes, sir. Yes.
So what is perpendicular distance? 1200 G sin 15, 0. So and moment means what?
Zero.
Force
Zero.
into perpendicular distance. And
Yes,
this
sir.
perpendicular
Zero.
distance is here what? How much? 0.
0, sir.
And what about this 1200 G cos 15?
Perpendicular distance is 2.5 meters.
So this perpendicular distance is how much, sir?
2.5 meters.
2.5 meter. You are getting my point?
Yes, sir. Yes.
Any doubt in this discussion?
No, sir.
So what you have to do? So you got it. And for this 1200 G cos 15, what is perpendicular distance?
2.5 meters.
2.5 meters. So things will become now in moment calculation, things will become what? Very, very easy. So what we have to do further? To go further, what we have to do? Draw this drawing properly. Try to draw the bigger drawing. Don't draw the smaller drawing. Because if you draw the bigger drawing, things will become properly visible. If you draw the smaller drawing, things will become very, very complicated. So please try to draw this drawing properly. Huh?
Yes.
ड्राइंग समझ में आ गई सर आपको?
Yes sir, yes sir.
कोई डाउट सर आपको स्टोरी में?
सर जो हम लोग जो ट्रायंगल जो 15 डिग्री फाइंड आउट किया था वो मेरे को ऐसा समझ रहा है कि 15 डिग्री the total sum is 180 degree, so 15, 75 and 90 degree and this side one.
Yes sir,
And,
this triangle sir.
Yes sir, yes sir, yes sir. And after that the mass, the 1200 g from the triangle, that 90 degree we are taking from the black line at the bottom, right now sir?
Yes, this one. Means
no.
this summation of these two angles. See this one.
Okay.
Summation of this one and this one must be 90 degree.
Okay.
Because they are perpendicular to each other, na?
Yes sir.
So if this is 75 degree, then by default this one will become what? 15 degree.
Understood.
You got my point? All points?
Yes sir.
Any doubt in this discussion?
No sir. अभी क्लियर हो गया है. जो मास का अभी आप बोला था ना perpendicular total 90 degree आना चाहिए. So already 75 degree है. So remaining 15 degree 90 degree आ जाएगा.
Yes, correct. Now, so before going further, please write down this discussion also.
Yes. सर वो स्ट्रेस का जो सिंबल दिया है ना सर, वो सिंबल का नाम क्या है सर, मैं भूल गया.
The name of this symbol, the name of this symbol is a sigma.
Sigma, okay, cool.
We will see this one in simple and stresses and strain. We will use this symbol a lot of times.
Understood sir.
But just for now, just remember this point. Just for now, this is meant by stress. Just you have to memorize this relation for just now.
Stress is force by area.
Force by area. That is what you have to memorize for just for now.
Okay sir. ये pi by 4 d square is for the
Area, cross sectional area. Pi by 4 d square. It is a circle area, na. So cross section of this cable is a what? A circle, na. It is a circular cable. Cross. You got the meaning of cross section?
Yes sir.
So this is a what? A circular cross section of the cable. So that's why pi by 4 d square.
Understood sir.
You got this point? Any doubt in this
Yes.
discussion?
No sir.
Now try to see the scenario here. Very simple discussion, not that much difficult discussion. So our target is what? We have to find out stress in cable. To get a stress in cable, we should have a force in each cable. And for that purpose, what we are going to do? We are going to take a moment about a hinge. About which point we are going to take a moment? We are going to take a moment.
hinge का moment.
We are going to take a moment about which point? Hinge. And
Yes.
here summation of moment is equal to 0.
Yes sir.
Why 0? Because here this ramp is in what? Equilibrium. And why it is equilibrium? Because it is a stationary. Why
Yes.
here ramp is in equilibrium? Because ramp is stationary. And whenever any object is stationary, then summation of moment about any point 0. And here which any point we have considered? Here we considered hinge and taking clockwise as what?
Clockwise is positive sir.
Clockwise as what? Positive.
Positive.
So this is what? This is for the sign convention. Why we are considering this one? This is for the purpose of what?
Sign convention.
Sign convention. Means here we are mentioning what? Oh, clockwise movement we have to take a positive and anti-clockwise movements, we have to take a negative. That is the purpose of this one, solo purpose of this one, nothing else here. Now try to see the scenario here. We will see each forces one by one. Now what is the effect of 2f sin 50 about hinge? What is the effect of 2f sin 50 about hinge? Clockwise, anti-clockwise?
Sir, it's clockwise.
So what is the effect of 2f sin 50?
It's clockwise.
It is
2f sin 50.
Clockwise, and
yes,
perpendicular distance is how much?
3.5 meters.
So perpendicular distance is what? 3.5 meter. So 2f, and clockwise means what? We will take a positive. So
yes,
2f sin 50, perpendicular distance is how much?
3.5 meters.
So perpendicular distance is how much? 3.5 meter. Then next thing will be what? What about next thing? This 2f cos 50. What is the effect of 2f cos 50? No effect.
2f cos 50. 2f cos 50 hinge का through जा रहा है sir. So it will be 0.
So it is passes through the hinge. As it is passes through the hinge, so effect will be what? A 0.
Yes.
So what? For now I am writing, but it is not necessary. It is depends on you. 2f cos 50, perpendicular distance is how much? 0. Then what about this 1200g cos 15? What about this 1200g cos 15?
1200g cos 15, उसका perpendicular distance is 2.5 meters.
And moment is how much? Clockwise, anti-clockwise moment?
Sir, moment is clockwise only.
Moment is how much? What? Clockwise. So 1200g. Moment is how much? 1200g.
Yes sir, 1200g cos 15.
Clockwise or anti-clockwise?
सर अभी हिंदी से देखिएगा तो एंटी क्लॉकवाइज जा रहा है सर.
Anti-clockwise, not a clockwise.
एंटी क्लॉकवाइज में जा रहा है.
So what of 1200g cos 15, and perpendicular distance is what? 2.5. So minus. So why we are taking minus?
एंटी क्लॉकवाइज.
And perpendicular distance 2.5.
Yes.
And then what is remaining now? Which thing is remaining now?
सर अभी साइन बाकी है और उसका मोमेंट तो 0 है.
Here moment is what? Because of the sign 1200g sin 15, it is passes through the, this 1200g sin 15, it is passes through the hinge point.
The hinge. And
So
it's also anti-clockwise direction.
no, here we can't say clockwise, anti-clockwise.
Okay. It's on the same axis.
So same axis. So here we can't say.
Okay.
Equal to into 0, and then summation of moment is equal to what? 0. You are getting my point?
Yes sir.
So now this one is what? 2f. So this term will become what? 0. And this term will also become what? This one? 0. So now which two terms are remaining? 2f sin 50 multiplied by 3.5 minus 1200g cos 15 multiplied by what? 2.5 equal to 0. So how much f we will have? F is equal to what? 1200 g cos 15 into 2.5 divided by what?
Sin
2 into sin 50 multiplied by what? 3.5. So 1200 multiplied by 9.81 into cos of 15 into what, sir? 2.5 into 2.5 divided by what? 2 into sin 50 into 3.5. You are getting my point?
Yes sir.
So before going further, please do this calculation. Always try to do the calculation.
Sir, 5301.295.
1 minute, let me check the values. Five three
01.29.
53
01.29.
2957 unit
Yes sir.
Newton. So in this way, what we got it? In this way we got it. What we got it? We got the value of F, and now we are nearer to our answer. So before going further, write down this discussion. 1 minute, let me check values. So what we have to do further, sir?
Now we need to find out the tensile stress in each cable. So tensile stress formula is force by area.
So force by area. So what we need, sir? Stress in each cable.
We already got the force. We know the dia. We can calculate by from stress formula.
So stress in each cable will be how much? Sigma cable. Force by pi by 4.
Pi by 4 d square.
So diop which d you have to take cable d. Remember.
Yes, yes.
So F is how much? 55301.2957 divided by what? Pi by 4. Diop cable is how much? How much they have given us? 15 mm means 0.015 meter.
Yes, sir.
So 0.015 square. So here we will get a what? Stress in cable. So how much value we will get? So if you put the values, and after getting the values, what you have to do? Press ENG button. So what we will get? We will get a 29.9999 something like that into 10 raised to the power 6. So force is in Newton, area is in meter square. So stress in the cable will become what? Newton per meter square. So we will take
सर अभी जो वैल्यू आया कौन सा बटन प्रेस करने के लिए बोला सर?
ENG button. There is a one button ENG button in calculator above the 8. There is a one button ENG.
Yes, sir, ENG. What does it mean, sir? ENG?
In engineering.
Okay.
So if you get this value, 29.9999 into 10 raised to the
power 6.
6.
Okay.
So it will become what? Approximately 30 into 10 raised to the power 6.
Yes, yes, yes.
Newton per meter square, and 10 raised to the power 6 means what? Mega. 10 raised to the power 6. Dekho, see, kilo means what? 10 raised to the power 3. Mega means what? 10 raised to the power 9. 10 raised to the power 6. So 10 raised to the power 6 means what? So stress in each cable will become what? 30 mega Newton per meter square. What it will become?
Mega Newton.
30 mega Newton per meter square.
So 30 into, if it is 10 power 3 is kilonewton, then 10 power
6 means what?
mega Newton.
Mega. So 10 raised to the power 6 means what? Mega.
Okay.
So that's why we have written 30 mega Newton per meter square. And why we got it unit Newton per meter square? Tell me.
Newton per meter square, this is force by area.
So Newton, force Newton, area meter square. So that's why.
Newton per meter square.
Correct. Very good. So please write down this discussion. Stress in the cable. So we got it what? Stress in each cable.
Yes.
Now, so this is what our A part answer. Now in B part, what is our target?
Shear stress in each of the hinge pins.
So what is our B part target? What we have to find out? Shear stress in what?
In the pins, hinge pins.
In each of the hinge pins. So here how many pins here we have? 2 pins. And each pin is in what? Double shear. Now what is the meaning of double shear? I am going to explain you what is the meaning of double shear. See, this is water. Try to see the scenario. We will see after writing these numericals, we will write down this theory also.
Okay, sir.
So this is the scenario of single shear. See, here we are applying a force F. Here we are applying a force F. Here we have 2 plates. This is a plate 1, upper plate, and this is a below plate. And these 2 plates are connected by what? This pin.
Yes.
So here what is going to happen? A shearing is going to take place, means if there is a failure of the pin is going to fail like this.
Yes. Yes. Yes.
It is not always like that it is going to fail, but it is going to fail what? Due to this,
Understood.
it is going to fail like this. So this is mean by shearing. And here we will have what? Here the stress which is going to generate, it is what? Shear stress.
Yes. Sir.
So then shear stress is equal to what? Force, shear force divided by what? Area.
Area. Area of the pin.
Okay, area of the pin. You are getting my point. So
Yes.
here this is what in single shear, means here we have only one shear plane. But if you observe this drawing, what does you come to know that? Oh, here we have what? A shearing is going to take place at what?
Two places.
Two places, means this is one plane, here like this, and here like this another plane. So
Yes.
means here we have connected a pin by what? Means here we have a three plates, plate 1, plate 2,
Three. Three.
plate 3. So this is what, in this case this pin is in what? Double shear, means here what? We have a two shear areas. So while calculating shear stress, what we have to consider? Here we have to consider 2 times area of a pin, means one single area multiplied by 2 times, because here we have a two shear planes.
Okay. Okay.
So that is meaning of double shear. And double shear means what? In this case pin is tries to be like this, so shearing is going to take place like this. In case of single shear, only like this. In case
Yes.
of double shear, like this. And in case of single shear, stress relation is what? F by area of pin, because here we have only one area.
Yes.
But here how many area? Here we will have two area. After this numerical we will write down the numerical. So and what is the meaning of F here? Where F stand for what? Shear
Shear.
force. What is mean by F?
Shear force.
Shear force. Now here try to see the numericals. We will come back to this numerical now. And if you observe this numerical, so here on this pin there is a reaction force is going to develop, and that reaction force, whenever there is a pin or hinge, if you remember our last numerical, what we discussed in last numerical, so whenever we have a scenario like this, there is what? A pin or hinge, their reaction force is going to develop, and that reaction force is like a shear force. Their reaction force is like a what? A shear force. So what? This reaction force will have a two component. One component is in what? X direction, and another component is in what?
Y direction.
Y direction. So reaction force will have a two component. One component is in what? X direction. So this component will become Rx. This component will become what? Ry. And how to get R? To get R, we will form this rectangle, complete rectangle. Try to see the scenario, and this R, and we are going to make this one, these lines as a what? A dotted. Try to see the things here carefully, and here we will have what? This will become what? Our R. And R stand for what? Reaction force, and this reaction force will act as a what? This reaction force R will act as a what? A shear force on this pin, on these pins here, on this hinge. Here it is a shear force, so this R will act as a what? You are getting my point?
Yes, sir. Yes, sir.
So
These components of the forces was acting on the pin.
so this is what R. Basically R is acting reaction force, and this reaction force will become is like a what? A shear force here. This R is what? A reaction force, and this reaction force will be act as a what? Shear force here. And this R will have a two component. One component is Rx, another component is what?
Ry.
Ry. And here we are going to assume this is what? Our X direction, and this is what? A Y direction. That is what we are going to consider. So what we are going to consider? This is what? Our X direction, and this is what? Our sir?
Y direction.
Y direction. So X direction, and this is what? Our Y direction. You are getting my point? Try to understand the scenario here further. So now before going further, what you have to do? Show Rx, Ry, R, this X and Y direction. What you have to show? Rx, ry and r, this x and y direction. Show all these things here on this drawing. Extra things here. So try to see the things carefully, what we have to do and how we are going to approach. So for that purpose, now see, here earlier, how we have taken the components of 2f along the ramp perpendicular to the ramp. How we have taken the components of 2f earlier? Along the
ramp and perpendicular to the ramp.
Perpendicular to the ramp. And how we have taken the components of 1200G?
That also along the ramp and
perpendicular to the ramp. But now, to get the Rx and Ry, what we are going to do? To get the Rx and Ry, now tell me this 1200G directly in which direction? This 1200G? This 1200G is directly in
center of gravity, sir.
So, this 1200G, it is in directly in x direction or y direction?
Y direction.
So it is directly in y direction. So while calculating Rx and Ry, does we have to take a components of 1200G? We don't. We don't need a 1 minute. To see 1 minute. Huh? Our target is what? Don't get confused. What is our target in B part? What we have to find out in B part? Let's see our target in B part. We have to find out shear stress in each of the hinge pin. What is our target?
Shear stress in each of the hinge pin.
That is what our target. What we have to find out shear stress in each of the hinge pin. And how to get that shear stress? So to get the shear stress in each hinge pin. How to get a shear stress in each hinge pin? So tau pin. How many pins here we have?
2 pins.
2 pins. Each pin is in how much? Double shear? Each pin is in what? What they said?
Double shear, therefore force by 2A.
Means 4A.
Yeah, okay, 4A. 1 pin having 2.
So shear force divided by what? 2 for each number of pins. 2 yes. For double shear. And into what? Area. And area will become what? Pi by 4. Dia of pin square. You are getting my point?
Yes, sir.
So here, area of pin. So here, how many this shear force R? Shear force R will act on how many areas? 4 areas. This is for what? Number of pins. These 2 for what?
Number of pins.
Number of pin. These 2 for what?
Double shear.
Double shear. You are getting my point?
Yes, sir.
So R means what here? R will act as a shear force. So R divided by what? 2 times 2 into what? Pi by 4 dia of pin square. So if we need, suppose our target is what? What is our target, sir? Tell me. To need a shear stress in pin, tau pin, what we need? Sir, what shear we need? Force. We need a what? Shear force. Shear force is what? Unknown to us. What we need, sir, here? Shear force. And shear force is unknown to us. That is what? R. And to get R, what we are going to do? We need its component Rx and Ry. What we need? We need its component Rx and Ry. And how to get its component? We will see now. So for that purpose, what we are going to do? This 2f. What we are going to do? We will consider the same 2f here. Same 2f here. Just observe this 2f. Whatever that 2f we have seen earlier, same 2f we are going to consider here. I will use a red pen to show the 2f. So this is what our force 2f. Now here, Rx and Ry is in what? X direction, Y direction. X we have taken horizontal, Y we have taken vertical. So now, but here the components that we have shown earlier, it is what we have shown earlier. Along the ramp, perpendicular to the ramp.
Yes, sir.
But now, how we are showing the X and Y here? Tell me, how we are showing the X and Y here? Horizontal, vertical. How we are showing X and Y?
Horizontal, vertical.
So for that purpose, we need a components of 2f in the same way, horizontal direction and vertical direction.
Okay, sir.
And for that purpose, and how much 2f will make angle with respect to horizontal? Listen my question carefully. How much 2f is making angle with respect to horizontal? How much this 2f is making angle with respect to horizontal?
40 degrees.
40 degree. How does you come to know that 40 degree?
Uh,
This 2f, suppose this I am showing 2f here. This
Okay.
2f, and this is what a horizontal line.
okay.
This is what a suppose horizontal line. How much will be this angle, sir?
15 degrees, sir.
No. 2f angle. So this is what our 2f. See the point. This 2f is making how much angle with respect to ramp?
50 degrees.
50 degree. And ramp is making how much angle?
15 degrees.
15 degree. So this entire angle will become how much then?
65 degrees.
65 degree. That is the correct answer. Very good. So then what is the scenario, sir, here? So this 2f, what I am going to do? I am going to draw. I am going to form a rectangle here. See this one? You are getting this rectangle?
Yes, sir.
So what we are going to do? This 2f, what is going to happen? So here we are going to form a rectangle. So this 2f is making how much angle with respect to horizontal?
65 degrees.
Any doubt in this 65 degree?
No, sir. No, sir.
And now why? And here we will have a two components of this 2f. One component is in what? X direction. See this one. And another component is in what?
Y direction.
Y direction. And why we are taking like that? Because our Rx and Ry horizontal and vertical. So for that purpose we need the components of 2f also in same direction. So this component will become 2f cos 65 and this component will become what? 2f
Sin 65.
sin 65. And what about this 1200G? Does we have to take a component of 1200G x and y direction? Is it necessary for 1200G?
Yes, sir.
Why necessary, sir? Why it is no?
Because 1200G is the RAM का जो weight है, sir.
But does we have to take a component of 1200G? We don't need a components of 1200G, sir. We don't need a components of what, sir?
1200G.
We don't need. Why? Because 1200G directly in y direction, na, sir.
Yes.
So we don't need a components of 1200G.
Hmm.
But in case of 2f, is this 2f? Is it in x or y? It is neither in x nor in y.
Okay.
So that's why we have to take a components of 2f. That's why we have taken the components of 2f. But in case of the 1200G, we are not going to take out the components in x or y because 1200G directly in what, sir?
Y direction.
Y direction. It is a vertically, na? But it is in negative y direction. We will see that one also further discussion. So before going further, what you have to do? Write down this target. Draw this figure. And then we will see our remaining discussion, sir. So please write down this discussion up to this point. Now what we are going to do further, sir? What we have to do? So we need a Rx and Ry, and to need a Rx and Ry, what we are going to do? We are going to take a what? Summation of what?
Summation of
Forces in x direction equal to 0.
yes, sir.
And why equal to 0, sir? Because this ramp is in what?
Stationary.
Stationary means equilibrium.
Yes.
So now try to see the scenario. What are the forces here? This 2f cos 65. This 2f cos 65 is in positive x direction. Then we have a Rx minus Rx. Other than these two, is there any other force in x direction? Equal to 0. So,
Yes, sir.
so Rx will become what, sir? 2f 2f cos 65.
Yes.
So 2 times f is how much, sir? F is how much?
5301.2957.
5301.2957 into what?
Cos 65.
Cos 65. So then we will get a what? Rx. So please do the calculation for Rx. So how much Rx we are getting, sir? It is a simple calculation. Now why you are taking time?
Actually, I am again looking into the diagrams how we are taking the RX.
Huh.
So 4480.84.
44
80
4480.8487
84.
Newton.
Yes, sir.
So we got it Rx.
Yes.
Write down up to Rx, sir. Now then, we will take a what? Summation of forces in what?
Y direction.
Y direction equal to what? 0.
Yes.
Here we will have a what? 2f sin 65
2f sin 65 and 1200G.
minus 1200G. Directly 1200G. Here we don't have to take any components because it is directly in Y direction. And then we will have what? Plus Ry.
So here also for the moment also we will be looking into this clockwise and anti-clockwise, no, sir?
Here summation. Here we know it. Here we are not looking at the clockwise anti-clockwise. Here we are taking upward positive, downward negative. This is not a moment, sir. This is summation of forces.
Okay. Summation में upward positive negative.
Summation of forces, sir. Summation of forces.
Okay. So in that case, the 2f sin 65 is a positive and 1200G. It will be negative.
Why? Because it is in downward direction. And Ry, why positive? It is in upward direction.
Upward direction.
So here we will get the what? Ry is equal to what? 1200G minus 2f
Sin 65.
sin 65. So Ry will become what? 1200 multiplied by 9.81 minus 2 into what? How much of we have, sir?
5301.2957.
5301.2957 into what? Sine of 65.
Yes, sir.
So please put all the values and try to get the value of Ry.
Two 2162.788.
21.788
62.788.
unit
Unit will be Newton.
Newton. So we got the Rx, we got the Ry. So please write down up to Ry. So now we have a Rx and Ry. What we are going to do? We are going to calculate R, and R will become what? Under root of what?
Rx square plus Ry square.
Plus Ry square. So under root of what? Rx square plus Ry square. So under root of Rx is how much we have? How much we calculate Rx? 4480.8487 square. Ry is how much? 2162.7888 square. So please do the calculation and tell me the value of R.
Four nine seven 4975.506.
How much? 7949
Sir, 4975.506.
75.506 Newton.
Yes, sir.
So we got the value of R. So in this way we got a value of R. And shear stress in the pin, what relation we have seen? Shear force R divided by 2 times pi by 4 into dia of pin square.
Yes, sir.
So here we will have what? 4975.5006 divided by what? 2 into 2 means what? 4. So we can cancel that one.
Yes, sir.
So we will directly write down what? Pi by 4.
5 into
0. How much dia of pin they have given us in the given?
0.03, sir.
So here dia of pin we have 0.03 meter. So 0.03 square.
Yes.
So put all the values in your calculator and we will get a what? Value of what? Shear stress in the pin. Press the NG button. And if you press the NG button, we will get a what? 1.75
1.759
7
59.
10 raised to the power 6 Newton per meter square.
Yes, sir.
And it means what? 1.7597 mega Newton per meter square. 10 raised to the power 6 means what? Mega. Don't worry, we will see all this discussion, all these things in detail when we are going to deal with simple stresses and strain part 2 chapter 1, sir.
Okay, sir.
So there we will see the discussion. Basically this question is from that chapter.